Planets and exoplanets are spherical, that's what we thought. But not for long. For the very first time in space exploration journey, scientists and astronomers has detected the deformation of an exoplanet. This exoplanet has a deformed shape, like a rugby ball. Without further ado, let's uncover the mystery behind the deformation of this star-hugging exoplanet. WASP 103b is a gas giant, which is located 1,255 light-years away in the constellation of Hercules. It has 1.5 times the mass and approximately 2 times the size of our Jupiter. The planet is orbiting an F-type star, WASP 103, at the orbital distance of approximately 0.02 astronomical unit. For comparison, Mercury, the nearest planet to the Sun in our solar system, is orbiting the Sun at the orbital distance of 0.4 astronomical unit. The orbital radius of WASP 103b is too narrow that it is tightly hugging its host star. Because of that, it takes less than a day to complete just one orbit. 0.9 Earth days, to be exact. This behavior would cause gigantic tides on the planet, and it is one of the reasons behind the deformed shape of WASP 103b. We experience tides on Earth, mainly because of the Moon. The Sun has minimal effect on tides as well, but it's too far away to deform and reshape our planet. However, the same can't be said for WASP 103b. The planet has already been discovered in 2014. Since then, astronomers have already known about the enormous tides on WASP 103b, but haven't been able to measure them properly until 2022. By combining new data from Cheops Space Telescope with old data from Hubble Space Telescope and Spitzer Space Telescope, astronomers were able to detect how tidal forces are reshaping WASP 103b from the usual sphere shape into rugby-ball shape. You must be wondering, why the rugby-ball shape? Couldn't it be another shape? How are tidal forces reshaping WASP 103b? To answer these questions, we must first understand how our ocean tides works. The Moon and the Earth have a gravitational pull on each other. The Moon's gravitational pull causes the oceans to bulge out like a rugby ball on both sides of our Earth. One side is the closest to the Moon, and the other side is the farthest from the Moon. In other words, the Moon is reshaping the oceans of Earth. As the Earth rotates through this rugby-ball-shaped tidal bulges generated by the Moon's gravitational pull, we see the tides rise and fall. And that is the reason why WASP 103b is inflated like a rugby ball. Susanna Barros, the lead author of the research, explains, the resistance of a material to being deformed depends on its composition. For example, here on Earth, we have tides due to the Moon and the Sun, but we can only see tides in the oceans. The rocky part doesn't move that much. By measuring how much the planet is deformed, we can tell how much of it is rocky, gaseous, or water. ESA, the European Space Agency's exoplanet mission, cheops, reveals the deformation of WASP 103b. Cheops measures exoplanet transits, the dip in light, which happens when a planet passes in front of its parent star from our point of view. The high precision and pointing flexibility of cheops enables astronomers to return to a target planet to observe multiple transits and then detect even the insignificant signal of the tidal deformation. Furthermore, astronomers use the transit light curve of WASP 103b to measure how mass is distributed within the planet and discover that the internal structure of the planet is very similar to our Jupiter. Scientists speculate that the planet must be very inflated like a rugby ball due to the heat from its host star, WASP 103, which is 200 degrees hotter and 1.7 times larger than our Sun. Jacques Lasker, co-author of the research, explains, it's incredible that Cheops was actually able to reveal this tiny deformation. This is the first time such analysis has been made, and we can hope that observing over a longer time interval will strengthen this observation and lead to better knowledge of the planet's internal structure. On the other hand, Cheops also uncovers another mystery about WASP 103b. Normally, the tidal tug between a star and a Jupiter-sized planet would shorten the planet's orbital distance, gradually moving closer and closer to the host star before the planet is engulfed by the parent star. But WASP 103b is doing the opposite and slowly moving further away from its star. According to the research team, this baffling behavior is indicating that there must be another dominant factor affecting this planet other than its massive tidal forces. Still, further observations with cheops and James Webb Space Telescope are required to decipher the mysteries behind the deformation of WASP 103b. The extremely high precision of JWST will enhance the overall measurements and upcoming follow-up missions. This one-of-a-kind discovery can tell us more about the deformation of the exoplanets and how they are formed, theoretically, in the near future. If you think this video is informative and entertaining, smash the like button and subscribe for more science contents. You should check these strange planets too. Thanks for watching.